Let's look at this example to understand more about what you have learned in the first lecture. The volume of a sphere is given by V equals 4 pi r to the power of 3 divided by 3, where r is the radius. Use MatLab to compute the radius of a sphere having a volume 40% greater than that of a sphere of radius 4 feet. So first, we open a new script file. To solve this problem in MatLab, we are advised to use the programming style. As stated in the lecture note of introduction, the programming style starts with comment section, followed by input section, calculation section, and lastly output section. You can read further about this in the lecture notes if you don't understand. Now, let's get started. We start with the comment section. Remember to put the %sign whenever you want to put a comment. We start with the file name. At the very first line, type what you want to name the file. Remember to put the .m at the end of the name. Here I named it radius sphere. At the second line, we put what we want to solve. In this case, we want to find the radius of the sphere. On the third line, we put the date and the name. You can put your name here. If you look in the lecture notes example, after the date and name, it is input variable. But since we don't have input in this problem, we skip to the output variable. Our output variable clearly is the radius of the desired sphere in unit of foot. Now we type the parameters given in the question. As stated above, the sphere volume formula is V equals 4 pi r to the power of 3 divided by 3. And this sphere volume is 40% greater than that of a sphere that has a radius of 4 feet, so we name it as V_4 to differentiate between the sphere volume that we want. As given, the radius of this V_4 sphere is 4 feet, so we put it like this. Now let's move to the calculation section. Remember that we don't have the input section in this case. So, in the calculation section, we put the ways to calculate the problem. In this case, we need to find V_4 first. Thus, V_4 is equal to the volume equation just now, but replace the r with RV_4. After that, we can obtain the V because it is 40% greater than V_4. Then, we rearrange the equation and find the R value. Here, to calculate the cube root, I use the nthroot function. In this function bracket, it needs 2 values. At the left, I didn't put a value, but instead, we also can put any equation that can produce a value. At the left is what we want to root, and at the right what value of the root. Oh, one more thing. Remember to put the parenthesis symbol after each of your calculations. It is to hide the calculation works and produce the desired final answer only. For the output section, we can use fprintf function to display our output nicely. In the bracket of fprintf function, put the apostrophe and write what you want to display. To display a value, you can put %f like this, and after you close the apostrophe, put a comma, and put the variable to replace the %f. The \n symbol is to make a space below this display to make it more proper. After finish coding, click Run to run the code and get the result.
I hope this video can give some additional knowledge to you in using MatLab. Thanks for watching. If you have any questions, feel free to scan the QR code to reach us. Bye, and have a good day.